Alright, another day, another laptop that needs to be saved. This time is an Alienware 17, model number P45E, that has a lot of fancy buttons everywhere, as you can see here, and it turns on by itself without me even pressing the power button. It also comes with these hooks that you can use to hang this thing on a wall and admire its beauty from a distance. Just like you can admire the trophy of my achievements on my right, which I will remove so that it will not blind you with its glory, so that we can continue working on this laptop.
Now the issue with this laptop is, as you can see here, it just powers by itself without me ever pressing a power button. But regardless, we're going to open it up, plug in the HDMI port so that we can see what's on the screen. And as you can see, there's absolutely nothing on the screen. And the reason for that is because, according to this guy, the GPU has an error code 43, which means the GPU isn't working. But in reality, what happens is the GPU is complete no detect. Only Intel GPU is showing up on the list according to the GPU Z, and according to the device manager, the GPU is nowhere near in sight. And I'm not surprised. After all, can you really trust a guy that looks like this? I know I can't. But regardless, we're gonna power this thing down, take it apart, and see what's inside. Alright, number one, we're going to disconnect the battery so that this thing does not turn on by itself, and see if we can identify the GPU. And hopefully we won't be needing the board that the Nathan supplied us with, in hopes that I'd be able to harvest any kind of parts that I may or may not need from this one, so we'll see. And before I move any further, I've already found something that I do not like. And that something is located right there. I do not know what this is, where it came from, and whether or not it was there to begin with. What's interesting about this particular board is that it's got this little, it's kind of a sticker that sticks on top of the memory chips around the GPU die. If we were to peel it off, I'm not exactly sure what is the intended purpose for this thing is, other than prevent the memory chips from getting cooled the most efficient way possible by the provided cooler. But in my opinion, you do not want any kind of middleman between the cooler and the memory chips. I don't feel confident leaving this as is, so what I'm going to do is I'm going to ditch this and replace them with pads, and then we'll see what the temperatures are, and if there's a problem, Nathan can put it back together the way it was. So who cares? Alright, let's have a look under a microscope and see what we can gather from the visual inspection. And I am already seeing something. Looks like somebody had already been soldering around here. I don't know exactly what was he doing, but he was definitely doing something. So there's a fuse in here that we can probably check. Let's check the fuse, and the fuse is okay. I'm guessing somebody had tried to solder this chip. Maybe he tried to reflow the chip. I don't know. But we having a no detect, and looks like we got some solder. Looks like liquid metal here. Yeah, look at this. We got some liquid metal, and let's get rid of that liquid metal from there if we can. Yeah, I don't know. What is it about laptops and liquid metals? They should not be friends if you ask me. But regardless, what I'm seeing is really nothing special. And so now I'm running into a problem. How do I go about testing this core, whether or not it has the voltages required for it to be detected to begin with? I have no idea. Getting this powered isn't going to be straightforward. The only thing that I can do at this point is just go around, check for measurements, make sure I don't have any short circuits anywhere, you know, things like that. These two are probably memory. No, that's not a memory. Where's the memory in here? Get 60, 70 on the memory, so that's good. Memory is good. 6. I don't know what this 11 ohm in here and what this 17 ohm here. But measuring everything else kind of makes no sense really, because the it looks like the main board does work, but something went wrong with the GPU and it just does not seem to work. And it looks like he already tried to either reflow the or reball the A1. And as a matter of fact, let me go ahead and see what kind of errors did he get when he was testing this GPU for memory before he sent it over. There, it looks like he had some A0. Oh, it's not A1, it's A0. Okay, never mind. So that would have been the second chip from the corner, which is going to be this guy here. But we're not having a problem with the memory. We're having a problem with the complete no detect of the GPU. Alright, so maybe if we get lucky, I will be able to power this thing by connecting this power adapter straight into the motherboard somewhere. Alright, I think I found the connector that I was looking for, and I am getting 13. I'm getting my 20 volts coming in here. Yeah, but how do you turn it on? We need to figure out where the on button is on this board. Alright, look at this. Looks like there is a power button right there. It's built right into the motherboard so that you can press it and the whole thing should turn on. So we will keep that in mind. Though, so this is ground and this is going to be the power switch here. So I need to be able to press this button when the board is flipped on the other side, so that way I can go around and check for measurements. How do we do that? We need to solder a wire. Okay, there we go. We got the wire soldered to that resistor and a capacitor. And now, as soon as that wire touches the board or the ground, we will be able to turn the laptop on and go around the board and check for voltages on the core. Now, I don't know if the core is going to wake up by itself or it needs to be woken up by the system loading. I have no idea. So, but hopefully we can see the core waking up, and if we can wake up the core, then at the very least we can say that the some voltages for the core are actually working. So we're going to flip the switch and we're going to touch that to the ground and see what happens. Okay, it starts to boot. I don't see a whole lot of power on here. I'm going to put some kind of a cooler on the CPU to make sure. It looks like the GPU is kind of warming up. I see all of the power stages working. So let's go and check for voltages around the core. So here we have 0.8. That's definitely core. I think this is PEX. We got PEX. And I don't know where the memory is though. It's not here. It's not there. I think we can just measure the memory at the capacitors. And I don't think we have a memory voltage. Yeah. What about this one here? No, that's not it. This coil here. This coil here. This is all CPU related. Where is memory on this thing? I have no idea. So let's figure out. Let's turn this thing off. Figure out where the memory is. And we're going to have to go around the board and measure every coil and see. So it looks like this would be the memory here, I think. Yeah. Okay. So let's power this thing on again. Okay. Now let's see if we have memory voltage. And we have no memory. We got the core, do we? Yeah, we have the core and we got the PEX, but we do not have memory voltage. And that's interesting. Why that is, I have no idea. So it looks like we're making progress here rather than having an error on any specific memory chip. We're actually having no voltage on the memory. Thanks, Nathan, for throwing a curveball at me. Alright, let's figure this thing out. Let's go over to the board view and figure out where the memory is on this thing. So that will be our memory right there. Yes, the memory is driven by these two driver MOSFETs. So the MOSFETs do have 13 volt in here. So we already tested that. But who is driving the driver MOSFETs? Let's look at the PWM pin, which goes through what appears to be 0 ohm resistor. No, I don't even know if that's going to be on the board. Let's see where that goes. Okay, so that's supposed to go, of course that would go all the way on the back of the board. Let's see, let's go on the back of the board. Alright, let's go back on the back of the board, right next to this little guy here. And this is going to be our memory buck converter. So let's see what happens when, yeah, we got 5 volts, so we definitely have VCC. We need to look for the enable. Enable is going to be pin number 2. It's going to be 1, 2. It's going to be this resistor here. So let's try to power the board and see what we're going to get on that resistor. Okay, so the board is powering and we have, oh, almost, we had it there for a second. Yep, we have enable. Okay, perfect. So next step to check would be the driver on. Let's turn this thing off before it overheats. I don't think we're gonna have power good here. Let's flip the board over and let's look at these driver MOSFETs. So I don't think we have a short. Let's check if we have any shorts on any of the pins, such as VCC. So we're gonna check this one here. That's PWM, no short there. So no short here. Nothing is shorted. Oh, we're not even testing anything. Hold on, let's connect the probes again. Let's see. What do we got here? No short. No short. That's a ground. That's the voltage in, I believe. No, the voltage in is gonna be here. Not short. Bootstraps, VCC. So that's gonna be this pin. So this one here is reading short, and here as well. But this driver MOSFET does not, and neither is this. So this one is definitely shorted, and it turns out that these two resistors here could be the problem. But we are reading 0 ohm here, and we are reading nothing here. But this resistor looks like it might have a hole in it. It's almost like it's got a hole on it or something. And that resistor supposed to be 2.2 ohm, and it is not. What's gonna happen if we inject 1 volt into here? So if I inject 1 volt into here, I will see what's shorted. It's most likely going to be the driver MOSFET. So we can just go ahead and inject the voltage straight into the driver MOSFET and see what happens. I want to see what will happen when I inject the voltage into that one capacitor. Oh, there we go. See right there. That driver MOSFET is toast. So let's go and replace the driver MOSFET so that at the very least we can get some voltages on that memory. I also want to replace that blown 2 ohm resistor, which Nathan never mentioned, and that's okay. There we go. Out with the old. I probably want to put a little bit of leaded solder on here so that it's easier to solder a new resistor. And I'm going to be taking a resistor from the book of resistors. That's going to be chapter 9, and that's going to be verse 11. Thou shall be placed. All right, let's go back under a microscope because it's more interesting in there than it is in here. And put that there. And maybe I can introduce a little bit of hot air to make it easier on the eyes and the ears. There we go. That was super easy. Thanks to Black Horse Repair Flux.
Thanks, Donnie.
Thanks, Steve.
The most amazing flux. The most amazing flux that exists.
The best flux.
Alright, so we got that replaced. Next, we need to replace that failed driver MOSFET. So, let's do that. Now, this is very unusual. Customers send you a laptop saying that it's got memory errors on some kind of a bank 0, whatever, and we end up having a broken driver MOSFET. There we go. Alright, let's bring in a new driver MOSFET. And let's solder this son of a diddly back to where it belongs. There we go. Let's fix these pins. That looks beautiful. Alright, there we go. That looks absolutely gorgeous. Now, do we still have a short on that pin? Let's have a look. Alright, here we go. No short. No short. No short. No short. No short.
The short is gone.
Gonna put a heat sink on the CPU. It looks like we have, do we have voltage on memory? Yes. We got voltage on memory. And the core is getting warmed up. Okay, so we're good. Perfect. Now we can, only at this point, I can go ahead and assemble everything and run some tests and confirm whether or not the problem actually exists. But that's going to be a lot of extra work. So what I'm going to do instead is I'm going to replace the chip in question, and hopefully that's all this is. Hopefully we won't have to worry about reball in the core or none of that, but we'll see. Alright, so we got it assembled. Yep, we still have a picture. Kind of makes me wonder if I could go into the BIOS. Okay, so looks like we can go into BIOS setup in here. Don't know if it's gonna show us the GPU inside the BIOS or not. And the GPU is there with a basic, hopefully you can see this, we got a basic adapter. So that's interesting. That means we need to download and install drivers. So let's do that real quick. Okay, so the driver picked up. It looks like we got a 2070 Super. It's not showing us memory or anything in there, so it looks like we have a problem with GPU after all. I'm gonna go ahead and run some memory test and see if I can either confirm or deny Nathan's claims regarding the GPU errors. Okay, we have an update. So I finally managed to run the memory test, and it does complain about this particular chip, just like it did before for Nathan himself, which means we're probably having issues under the core, or maybe there's liquid metal under there, I do not know. So bottom line is we're gonna have to lift the core, look what's under there, and most likely get that thing reballed. Hopefully that helps. If that does not help, then we are screwed. Let's turn on the heat, position the probe, and off we go. Alright, so this thing is playing hide and seek. I do not see the graphics card in the device manager anymore, not even in the BIOS. Don't know what went wrong. Maybe there's a gray pad under the core that did not solder all the way. I have no idea. All of the voltages look good. We have PEX, we got memory voltage, everything looking good. I did not check. One thing I did not check would be the crystal oscillator, and I also did not check for bias. But I don't think a bias would have anything to do with it, because even if the bias was corrupt, I'm 99% positive that the BIOS would still show the GPU in the BIOS. As long as we don't make it worse, I'm happy. As a matter of fact, we made it better already, because it came with no memory voltage to begin with. But now we have memory voltage, but it's playing no detect. Back on the preheater, and we start again, unfortunately. Alright, so I did not reball the core. What I ended up doing was I went to Nathan and I cried to him about his laptop, and he said that on this particular model, out of all laptops in the world that he had ever fixed, this one has a problem with the crystal oscillator next to the GPU, and he suggested that I would replace it, and I did. So, and come on, give me, nope, still don't detect. Oh well, reball it is. Alright, looks like we're finally making some progress here. It turns out that the GPU die was not connected on the bottom corner over here and a little bit over here. I'm not sure exactly why. Maybe the board got sort of warped or something, and the core was kind of sitting on its belly a little bit, so I put a little bit of weights, but now we can see that the 2070 is showing up. Let's go and escape the BIOS and see if Windows will show us anything good. And I'm gonna look into the device manager. I know it's a bit cheesy for you to see it. No, looks like we got an error code 43 still. So looks like the problem is either the core itself, but we're gonna have to run the memory test and confirm. So I'm gonna go ahead and run the memory test one more time. And funny thing is, you have to run the memory test from from this USB port, not this one. Otherwise, it's not gonna work. All right, we are done here today. The error remained on the exact same chip, which means this GPU is dead. So I'm gonna turn this thing off. Now, I don't know if the other GPU is alive that he sent over with this donor board. It's all scratched up and marked off, so I would imagine it's probably not alive. What is wrong with the existing GPU on the donor board? I wonder if that can be salvaged, and maybe it was misdiagnosed. Who knows? I'm gonna check for a short on the core. So, no short on the core. The core is not shorted. And the memory is dead short. But is that because... yeah, the dead short on the memory could be because some of the pads that are here that are short. So let's take care of those pads really quick. That will break away the memory rail from the ground. At least the way I see it is what's going on in here. I don't know. So that should be enough. Okay, let's try again. Yeah, we're reading good on memory. What about PEX? Ooh, PEX is short, but I wonder if PEX is short inside the core, or is it short somewhere on the board? So let's have a look. And here goes nothing. Why am I not getting a ground? What is wrong with ground today? Is this good? Oh yeah, so the short is not... The short is on the chip. So we could probably remove the chip and see if the short will go away. So maybe we should do that. Let's do that. There's a significant blowout in here, but I think if we just remove... I think that if we just remove the shorted coil, we might just get away with that. I don't know. Let's give it a try. We got nothing to do anyway. Saturday, it's 10 o'clock. I gotta go sleep so I can wake up tomorrow. And if I don't go sleep anytime soon, I will probably end up getting a migraine, just like I did in the last 2 days. So today is finally migraine-free day, and I am here giving myself a migraine with these repairs. All right, there we go. The chip is off, and hopefully that's all there is. Hopefully the short was just on the input side of this. Hard to say. Let's cool it down real quick. Yeah, very unfortunate chain of events today, definitely unexpected, but it is what it is. Sometimes you put all that work into nothing and get nothing in return. All right, what do we have now? Are we still reading short? Okay, so we're reading 7 ohms. So we're reading 7 ohms here. We're reading good memory. We're not reading any short on 1.8. No, we do not. And data line is not shorted. So I think this core here deserves a second chance. So I'm gonna get this core off the board and deal with it tomorrow. Alright, another day, another headache that needs to be fixed. This time it's that exact same Alienware that we got 2 days ago, so 2.5 days later, I actually got it fixed. And all I had to do is to simply steal the core from the donor board that was provided alongside with the laptop, and it only took about 3 reballs to confirm that the original core and the original board was busted, and it only took about 3 more reballs to actually get the donor GPU to sit flat on the original board because it just refused to solder on that one particular corner over here for whatever reason. But who cares how many times it took? As long as we get to the end result, that's all that matters. As a matter of fact, let's go ahead and try the HDMI cable. And if everything's working correctly, we should get a display coming out of the HDMI cable right away. And we're waiting. Let's see, it should do its self-adjustment and all that kind of stuff. Detect display. See if I can go into display detection here. It should, I think it should start switching anytime now. Maybe I need to change resolution to 1080p so that it would match the resolution of the splitter and the HDMI switch. And it is not detecting any displays. So I'm gonna pull out the cable, wait, and try again. Hopefully that works. Still does not work. So some issues with the HDMI port from what I can see. Yep, there we go. So it looks like there's some issues with the HDMI port. Probably dirty or something. I don't know. Who cares? All right. So there's our GPU. 2070. Let's do a run like a 800 by 400 mark. So I don't really care at this point about the temperatures or whatnot, because all I did was apply some paste just for the sake of the demonstration. And we can run some kind of a test for the game to make sure that everything works. Oops, something does not work. 16 full, okay. Something about the screen resolution that it does not like. Let's figure this out. Close this, try one more time. So it's 1920 by 1080 FHD. Let's see if that works. All right, there we go. We're starting to load, finally starting to load the benchmarks. And there we go. As you can see in the upper right corner, the RTX 2070, everything is working, no artifacts. The system seems to be stable. So with that said, I'm going to conclude with this repair, shut everything down, and hopefully this video was as depressing for you as it was for me, because 2.5 days to get this thing fixed was not an easy task, but I had nothing better to do anyway, so who cares? We got it. The one thing I'm going to leave the Nate to deal with would be to put this piece of plastic back in, because I do not want to take this thing apart anymore. Yeah, I'm completely burned out by this. And I will also keep the donor board without asking for his permission, so that I can harvest, yes, I want to harvest that battery connector. That's right. That's all I want this for. Nothing else. And I'm going to be sending this thing here for the memory cooling, though I ended up putting some pads on there. He can put 1mm pad on there, It'll work way better than what this thing does. I'm not even sure what this thing does. It doesn't seem to do anything. But I don't care. The only takeaway that I can get out of this video is that I hate Dell laptops. Particularly this one. Especially ones that need to be reballed. And if you're thinking that anybody can do a reball, think again. If it took me, someone who reballs things day and night, 6 attempts to get this thing working, how much luck do you think the person who doesn't do this every day like I do will have in order to get it fixed? Special thanks to Nate, who is probably the smartest one of all of us, because he knew what not to do. And he knew that sending this over to me for a reball would be a nightmare. I guess that was his punishment for impersonating his voice on my earlier video. But I don't care. It is what it is. Content is content. Who cares? Goodbye.